right, guys, we are going to cover the last lesson of chapter 6, and it's actually a pretty quick lesson. We just have 2 theorems with a few example problems to follow, so it shouldn't be that long of a lesson. Good way to end the chapter. So let me present and we'll get started. All right, so for this last lesson, we're going to cover the hinge theorem and the converse of the hinge theorem. Okay, the hinge theorem says if 2 sides of one triangle are congruent to 2 sides of another triangle and the included angles of the first triangle are larger than the included angle of the second, then the third side of the first is longer than the third side of the second. I know it sounds confusing. It actually is not that bad. All right, so if you look at the information that's provided, what's given, what's marked in the diagram, okay, you can see that this side is congruent to that, and this side is congruent to that, and then you're given an included angle. So you're given information about 2 sides and an included angle, one included angle. It's not side angle, side congruence. Those angles are not congruent. But what you're going to be able to do when you're given information about 2 sides and an included angle is make a conclusion about the third side, the side across from the included angles. So what this theorem says, the hinge theorem says, is that the larger angle is going to be across from the longer side. The shorter angle is going to be across from the shorter side. So if I'm comparing the 2 triangles, I can say, okay, the triangles are not congruent. I can see that, right? But I can make a conclusion. I can say that XW is greater than TS. Or if I want to say less than, I can say that TS is less than XW. Okay, so either or. So that's using the hinge theorem. Again, you're given information about 2 sides and an included angle. You'll make a conclusion about the third side. The converse of the hinge theorem, if you're given information about all 3 sides, so one side is congruent to another, a second side is congruent to another, but the third sides are not congruent. So again, I can't say the triangles are congruent. This is not side congruency, right? But what you can do using the converse is make a conclusion about a pair of angles. You look at the 2 sides that are not congruent. The longer side is across from the larger angle. The smaller side is across from the smaller angle. So I can compare angle C to F and say the measurement of angle C is greater than the measurement of angle F. Or if you want to flip it around and say the measurement of angle F, you'd say is less than the measurement of angle C. Okay, so that is what the entire lesson is based off of, those theorems. All right, we're actually only going to do 2 example problems, example 1, example 2, and then we're going to go to the extra practice. So we're skipping over most of the actual notes in this lesson. All right, so look at the information that's given. Notice the 2 triangles share PS. They have PS in common, so I can mark that as the reflexive piece. If you want to redraw the 2 triangles, like slide them apart, you can. Sometimes that's helpful. But you're given information about a side, a side, a side, a side, a side, a side. So I'm going to be using the converse of the hinge theorem, which says look at the sides that are not congruent and make a conclusion about the angles opposite them. All right. So the longer side is across from the larger angle. I can say that the measurement of angle S is greater than the measurement of angle P. Okay. And that's using the converse of the hinge theorem. The longer side, if you compare the 2 sides, the longer side is going to be across from the larger of the 2 angles. All right. And the hinge theorem for problem number 2. So notice in this example, you're given information about a side and this side. The reflexive piece, I can mark KM congruent to itself, and then you know the included angles. So when you know the included angles, but they're not congruent, you're going to make a conclusion about the opposite side. The larger angle is going to be across from the longer side. So I can say that JM is greater than LM. Or if you want to flip it around and say that LM is less than JM. All right, let's do a few more examples. Let's scroll down. We're going to, like I said, skip those and we're going to jump to the worksheet. Okay, so these are all quick. We're actually going to do all the problems on this worksheet, which are 9 problems, then we'll be done. Okay, so we're going to first complete the sentence using less than, greater than, or equal to explain your reasoning. So we're either going to be saying it's the hinge theorem or the converse of the hinge theorem. All right, I see that I have side, angle, side, angle, side, but the angles are not congruent. So I'm going to be using the hinge theorem to make a conclusion about the opposite sides. BC compared to EF, well, it's across from a smaller angle, so BC is less than EF. Okay. Side, angle, side, angle, side. So again, I'm going to be using the hinge theorem. Look at the given angles, look across. We're going to make a conclusion about the opposite sides. Larger of the two angles is 95, so longer of the two sides is BC. BC is greater than EF. Side, angle, side, angle, side. This time, notice the angles are congruent. Well, aren't the triangles congruent by side, angle, side congruency, side, angle, side congruency? So BC is equal to EF. Okay. Again, I know that triangle BAC is congruent to triangle. Notice how you named it. Make sure matching pieces match up. BA and EF or ED, excuse me, ED are congruent. So EDF, those are congruent triangles by side, angle, side congruency. And if the two triangles are congruent, that means that all parts of the triangles are congruent. So BC is equal to EF. All right. So those were all hinge theorem problems. Now let's look at some converse of the hinge theorem problems. All right. In problem 4, I'm given information about all three sides, but in this case, all three sides are congruent. So that means the triangles are congruent. Triangle ABC is congruent to triangle. Notice how I named it. A to B, B to C. So I have to name it D. Oh, no, I don't. I have to name it E. D, nope. How am I naming it? Sorry, guys. DEF. DEF. My eyes were playing tricks on me for a second. And that's by side, congruency. So if the two triangles are congruent, that means that corresponding angles, angle A and angle D, are congruent to each other. They're equal. All right. In the next example, you're given a side congruent to a side congruent to a side. The third sides are not congruent, but you're going to make a conclusion about the opposite angles using the converse of the hinge theorem. The smaller, shorter side is across from the smaller of the two angles. So angle A is less than angle D. Side, those are congruent, but the third sides are not. So make a conclusion about angle A compared to angle D. Angle A is across from a side length of 9. Angle D is across from a side length of 2. So angle A is greater than angle D. All right. Last 3 problems of this lesson. So in this example, you have a side congruent to a side, and then the reflexive piece AD is congruent to itself, and then your included angles, right? So this is going to be the hinge theorem. What can you say about the side across from 135 compared to the side across from 145? The larger angle is going to be across from the longer side. So AB is greater than AC. In problem 8, you're given information about a side and angle side, but they're all congruent to each other. All right. So if everything in this triangle is congruent to everything in this by side, angle, side congruency theorem, I know that AB is equal to DC, right? Because triangle AEE is congruent to triangle DEC by side, angle, side congruency. So that means that all corresponding pieces are congruent to each other. We learned that in the last chapter. And the last problem here. Okay, I can mark my reflexive piece. CB is congruent to CB. If you find it helpful to slide them apart, redraw the diagram, sliding them apart. I'm given information about a side congruent to a side congruent to itself, but the third sides are not congruent. So I'm going to make a conclusion about the angles across from the third sides. All right. The longer side 19, right? 19, 17, 19 is longer, is going to be across from the larger angle. So angle 1 is greater than angle 2. All right, guys. That is it for the 6.6. That brings us to the end of chapter 6. I'll see you back here for the next video lesson when we start the next chapter. Bye.